Okay, hi everyone. Profile, debug, analyze. Uh, do we have visual? No, we don't. Just give me a sec. Let's see. There we go. So once again, profile, debug, analyze. So that's the what of this presentation, and we're going to talk a little bit about tools. But before we start, just a really short introduction. Why? I guess since you're all here, you probably know why you came here. But I just wanted to talk a little bit about app quality. And that's something I really care about in apps. And that's actually part of my job, to try and increase app quality by talking to you, talking to developers like you, and helping you work on your apps, work on the app quality, and make it better. Now, I keep saying quality, but what is it really? For every person, for every developer, for every user, and even for every app, it'll be something slightly different. But I guess even now, in your head, you can name one or two things that have a direct impact on app quality. And I'm sure you can find it in this very short list here. It's anything from an app having a very small impact on battery life, so that the user is happy that their devices don't run out of power by the end of the day. It's about responsiveness, the way you launch an app, or if you switch to recents and then back, how fast the app starts. Also, when your app is in the background, how do other apps respond? Is the app you're actually using being impacted by your app running in the background? It's all about application size, download speed, installation time, a smooth UI when you're actually scrolling through a long list of items, and basically everything that makes the user happy, but also everything that doesn't impact the system, the device the user is actually using. So when working on an app really consists of a few things, right? First of all, you need to have the features, and that's really not something we're going to be talking about. That's your business. That's literally the reason the user wants to download your app. And then there's UI design. I'm not a designer, so I'm not going to give advice on how to make your app better in quality by better UI practices. But then there's correctness. When I have an app, I want to use its features. I'm interacting with the UI. Whatever I do, I want it to have the effect, the intended effect. I want it to do the thing I want to do. I want to buy tickets, I want to get a cab, I want to do something with the app, and it has to work. It can't just crash or just not do the thing I'm trying to do. And then there's performance, which I briefly noticed. So whatever I'm doing, even if I love the features, if I have to use it, if I'm trying to, I don't know, pay for something because I need it, I also don't want to be angry every time I do it. I don't want to be frustrated by how the app works and how my device behaves. So we're going to focus, I'm going to focus in this talk on these two things, correctness and performance. And the important part for you, developers, is to have the good tools and to understand them and know how to use them to actually care about these two things in your apps. And when working on an app, on performance, on correctness, on app quality, I see the work of every developer as having to be proactive and reactive. And what I understand by that is, even before you start actually implementing stuff and then releasing your app, first to beta testers, then to the market, you have to start by planning performance, planning any problems that you might run into, and then measuring everything and profiling. I mean, how can you know if an app starts quickly if you haven't planned for what the quick start is? Do some research, try competitors' apps, make some baselines that you strive to achieve, and make a plan. Even if you make a release, if you haven't hit those projected times or application sizes, you can always work on that. But it's important to actually have a plan and have a person responsible for these things. And then to just keep measuring and profiling your app while developing, before release, to make sure you reach those goals. And then once you release, the work is not over. You have to be vigilant. You have to see what's happening with your app. There will be users using devices you've never heard of, never even tried when developing on. And you have to monitor the situation and you have to be reactive, you have to debug any problems, and then fix them, hopefully, for the next release. So after this quick intro, let's move to talking about some new tools. And I'm going to talk about some new stuff in Android Studio 3.0, which is currently in beta, that we've announced at Google I/O. And I'm going to talk you through some of the tools we're offering. And then I'm going to, in the later section of the talk, I'm going to give you some short tips about debugging common problems that I ran into or that I heard other developers have problems with. So the first big thing, the Android profiler. Before Android Studio 3.0, we've had this section in Android Studio. One of the bottom windows was actually named Android Monitor, and we've had some pretty nice tools for graphing CPU usage and so on and so on. We are completely revamping this view in Android Studio 3.0. It's completely rewritten in the way it works behind the scenes and also in the UI. And now it's called the Android Profiler. And when you launch it, when you launch your app on a device or an emulator, when you just click on the Android Profiler, you will see, the first thing you see is the unified timeline. On this timeline, you can actually see an overview of the CPU, memory, and network usage of the app, which I'm going to go through in depth in a second. But why we're calling it a unified timeline, you also get this track at the top, which actually shows you some important app events, like input events, whenever you touch the screen, or input like key events. You see some other events like rotations, which obviously impact how your app works because the activities usually get destroyed and recreated. And then you actually see the activity state. So here I can see some kind of journey through my app when I launched the main activity, then was stopped because I probably pressed some button, moved to another activity, then rotated the screen, so it was, again, destroyed and recreated. So this helps you actually find your place on the timeline and see what impact what you're doing in your app actually has on the CPU, on the memory, and on the network. So that's the overview. You can glance at it, you can already get some information from it, but what's really nice are the detail views. So whenever I click on one of the timelines on the CPU, the memory, or the network, I can go into that detail view, and here I can see the CPU profiler. And the UI is quite complicated, but it's actually really nice to use. And let me just walk you through all the parts. So here on the left, you can see a thread list. These are all the threads that are running in your app while you have the profiler open. By the way, this is all the time when I'm showing you static screenshots. But whenever you're in this profiler view, this is a live view. So it keeps going left, the timeline keeps moving, you keep seeing like a live usage of everything. Whenever a new thread comes up, you will see it on the list. And also, here on the chart, you will not only see CPU usage, these are these green graphs, but you will also see this dotted line showing you how many threads are active at the time. So you'll see, as you spin up new background threads, you will see this going up. And then you see thread state. So there's a long list of threads, but not all of them are doing something at a given time, right? So probably you will see a lot of activity on the main thread whenever there's some UI stuff happening, and then you can see whenever your network threads, your other background threads are doing something, whenever they're active, whenever they're waiting on I/O, and so on and so on. And so here, again, I have this track showing me the app events. And I can see that whenever I actually scroll a list, here I was touching the screen, or wherever I switch activities, the CPU chart goes up because something is happening in my app. Now, I'm not alerted by the actual graph here. I'm not using like all CPUs 100%, so that's not something I'm concerned with. But still, let's say my activity is taking a long time to show up on my screen whenever I rotate my device. And I want to know more what's happening whenever I do that. So what I can do is actually start method tracing. This is the record button here at the top. And there's two ways you can trace your app. By default, the sampled tracer is enabled, which actually checks every X milliseconds, whatever method is running in your app. This is nice. It has low overhead, so you can get pretty accurate measurements. The other way you can do that is switch from sampled to instrumented. In instrumented, we'll actually measure every method enter and exit so that you can accurately see every method that ever ran in your app. But just be advised that this has some larger overhead. Okay, so what happens when I actually press start recording a method trace? Then simply run your app, run the section of your app in your emulator or in your device that you want to profile. And after you finish, press stop. And after a few seconds, when the system loads the trace, you will be greeted with this screen. So here at the top, I can see the selected slice of time whenever my trace was running. I can simply click on it or drag with the mouse and select the slice I'm interested in. And the default view here at the bottom is a call chart. And it seems pretty complicated, but it actually gives you already a lot of information at a glance. Since it's probably hard to see, I can actually zoom in either by selecting a smaller slice here or by simply using the keyboard and mouse on the flame chart here. And just by looking here, from the top, if you go from the top, this is like at the top, it's like a root method of a thread. So going down, I can see the calls going deeper and deeper in the stack hierarchy, right? So somewhere here, there's my activity on create. And all these bars actually represent, the width of the bars represents how long the method run in time. So if I just glance on that, I can see my onCreate here shown in green. By the way, green are all the methods that are in my app code, whereas yellow are the Android framework code, and blue are Java standard library methods. And I can see in my onCreate, there's obviously some view inflation happening. I can try to optimize that, but it's not a big problem. View inflation will always take some time. But then I can immediately notice I'm doing some weird stuff here. I'm actually getting a cache there and creating a cache folder for my images. This is all happening on the main thread. See, the main thread is selected here, and I'm looking at a trace of the main thread of the app. And I can immediately go and see, like, this is wrong. I shouldn't be initializing all that in my onCreate. That's why my activity is taking so long every time I rotate the screen. I have to do disk reads, I have to initialize the cache, and so on, so on. So this is one way you can immediately spot problems in your app. Now, there's more ways of looking at a trace if you switch the tabs here. So you can actually get a list of methods, including the relative times that they took to execute. Here in the top-down view, it's very similar to the call chart. So you start from the thread root, from the main method, and then you can dig in until you find, let's say, onCreate. Another way to look at it is by switching to the bottom-up view. And here, you actually, at the top of the hierarchy, of the tree hierarchy, you get the methods that were at the bottom of the call chart. So I can actually find my get disk cache dir here and see that it actually took a substantial amount of time to execute. And then, by digging in, I'm actually going the other way around. So I can find who was calling that, who initializes the cache. And I dig in, and I see my onCreate here. And so in that way, I know where I have to go and optimize my code. This is also great if you have problems when scrolling lists, if you're doing some custom painting in your widgets, and your frame rate drops. You can go and dig in and find these draw methods, these draw calls, or creating views in like a list adapter, and figure out what's taking so much time and how can I optimize it. Okay, moving on. Memory profiler. That's the second chart we saw on the unified timeline. And again, as an overview, you can see a live memory usage here. Whenever you switch activities, I probably start loading some more images, I start populating the caches and so on. I can see the memory going up. I can also see some more events here. So I can see the garbage collection happening. If you see too many of that icon, maybe you're thrashing the memory, maybe you're creating too many objects that have to be garbage collected. If you're doing that, again, when scrolling a list, that's probably a bad sign. So just by glancing at that, you can already spot some problems. But then the really nice thing about the memory analyzer and the memory profiler in this new tool is, yeah, so I was talking about events. You can actually, force a garbage collection too. But the really nice thing is, without any recording, and that's only on Android O devices and emulators, without actually starting any recording like I did in the CPU profiler, I can select at any time, I can select any slice from this graph and see all the allocations and deallocations that happened. So if I'm interested in this large increase in memory use and these garbage collections that happen here, whenever I scroll something in my activity, I can just simply select it at any time and see all the objects that were allocated and deallocated, and even how much memory they are taking up. There's obviously nicer ways you can look at this. So if you arrange by call stack, you can actually see where these allocations happened. And again, looking at the example of an adapter view of getting views every time you scroll a list, you probably know this pattern. There's like view recycling happening, so whenever a list needs to show a new item, it needs to obtain a view, then get a view, and then your code runs, and you're loading images. And when you're loading images, you create some workers, and so on and so on. You can see all that simply by selecting a slice of time on the timeline and digging into this. And then there's one more way of looking into it. If you're only interested in objects that you actually create in your own code, you can actually arrange by package and then see which objects from your libraries, from your code, are actually being created. So that's pretty nice. By the way, like I said, this works on Android O devices and emulators. If you're running on a lower API device, you can still do that, but there will be a record button here, just like in the CPU profiler. And you will have to actually record the allocations. Minor inconvenience, but if you can, just use O devices. Another nice thing you can do once you're interested in a class of objects that are being allocated, you can actually select it and see all the instances and when they were created and when they were destroyed. What's more, by clicking here on one of the instances of the objects, you can actually see the stack trace and see the exact place when they were created. So again, I can see all these objects were created in my get view. And maybe that's a place I could optimize to stop thrashing the memory and stop just creating and destroying objects every time a scroll happens. There's one more thing you can do. So previously in Android Studio, we had these two separate tools, an allocation tracker, which did just what I showed you, and then a heap viewer. So this is integrated in one tool now. So the other thing you can do with that is at any moment of time, if you click this action, dump heap, Android Studio will basically dump the memory contents of Java objects in your code, and you will get this list of all objects that existed in your app at the moment you click the button. You can again see it here on the timeline, and you can just click it to come back to it. And then whenever you select a class, you can see roughly how much memory this is creating in your app. And then you can see all instances of the objects you're interested in. And just as if you were connected and debugging an app, you can actually inspect all the members, all the fields, basically what the state of the object was. This is pretty useful if you get your application into some weird state. Let's say you were doing some fragment transactions and then something weird is appearing on the screen. You're not sure what's happening in your fragment, if it's attached or detached, whatever. This is just one example of a situation. And then you can actually find your fragment here and just examine the fields and see what's happening and then figure out how it got into this state. Another way you can use this is by selecting an instance of an object. You can actually see all references to it. So this is useful for debugging memory leaks. If at any moment of time you dump your heap and you see an object you think shouldn't be there, let's say you move through a few activities and really the previous activities should be destroyed, they should not be taking up your memory anymore, but they're still there, you can figure out who is holding on to it. And then you get this reference chain with this number here, depth, telling you how far from a root, so from something that is keeping your object in memory, how far is it to your object? And you can figure out what's holding onto it. Usually it's a view holding an activity, or you're just holding something in a field that you just shouldn't be doing. So memory leaks. Okay, and finally, the third tab is the network profiler. And this is something completely new. We didn't have that in Android Studio before, at least not implemented in this way. So for an overview, one thing that's in addition to the events track, now you also have a radio track. And this basically shows you 3 states. If you're on Wi-Fi, if the radio was on high energy use or low energy use. And what these are is basically whenever there's no network usage across the device, the radio can be powered down to conserve battery. And then whenever you start requests, whenever you need to hit the network for anything, Android will wake up the radio, it'll use the data connection to pull down the data. The thing is, this is very expensive. And just spinning up the radio, putting it into a high-powered state, first of all, it takes a lot of energy. And then once you're done with your requests, it'll take some time until it actually goes down to a low-energy state. And just by looking at this line, you can figure out if your app is batching network requests correctly, which means if you run your app for some time, let's say for 5 minutes, play with it, or wait till it does some background processing. If you keep doing requests every 30 seconds, then the radio will never go to a low-powered state, which means you're wasting battery, basically. Now, if you batch all your network requests, if you prefetch data when the user launches the app, and then you're done, then you can actually verify that your app is not keeping the device in a high-powered radio state. And the other thing you can see here is, of course, data transfer. So, maybe here you have data plans that are like unlimited data, or you have Wi-Fi on every corner, and you don't care about data usage. There are places in the world where users will be using your apps. They pay for every megabyte of data. They don't have Wi-Fi in every cafe on every corner, and they really care about this. So just try your apps and see how much data they're pulling. But again, this was just an overview. But the real power of the network profiler is that by selecting any slice of time here where requests were made, you actually get something like a list of HTTP requests, something like maybe from Chrome DevTools, where you see all the requests that were made. HTTP or HTTPS works. You see the size that was downloaded. You see the type of the payload, the status, if it was successful, and how much time it took. It's a great tool for debugging any problems with any kind of server APIs, pulling down images, anything basically you might do from your app that hits the network using HTTP. And by clicking at any of these requests, you can actually get a nice preview of the images that were pulled down, of JSON data, of XML, and then some nice statistics about whatever was pulled down, and even examine, of course, all the headers that were sent and received, and even get a call stack on wherever this request was made from your app. So that's pretty nice. And like I said, this works great, especially on Android Oreo and devices and emulators, where you can debug any APK that's debuggable and profile any APK that's debuggable. If you have a device or emulator that's on Nougat or before, some features will not work. Some features will require additional steps. And the thing is, you can't profile any APK. It's better to actually have a project open in Android Studio and always deploy your APK from Android Studio, build and deploy it. And that way, Android Studio can instrument your app to actually show all these cool things in the profilers. Okay, one more thing. If you actually work with APKs that are produced by some other build system, maybe you're a game developer, maybe you're using Unity, and also would like to use these profilers to see what's happening in your app, we have this new thing called APK debugging in Android Studio 3. And it's basically a new type of project. You start it by selecting profile or debug APK from the main Android Studio launcher. And then you simply select an APK created by whichever build system or wherever it's coming from. And Android Studio creates like a dummy project where it imports your APK, opens it in the APK analyzer, and then you can browse the Java code, decompile to Smalley, and you can browse the native libraries. And of course, it'll be nice if you have the sources for that. You can attach Java sources, you can attach native libraries with debug symbols, and then you can simply debug and profile the app as if you had the project open in Android Studio. So that's pretty nice. And speaking about APK Analyzer, we also have some improvements for that in Android Studio 3. Now, if you're not familiar with that, although it's been in Android Studio for some time, this is a tool mainly for debugging size problems with your app. So if your app's too big, you can look at resources and so on. To launch it, simply select Analyze APK from the build menu. The thing is, many developers make the mistake and select an APK created by Android Studio during development. So whenever you press the play button, the run button in Android Studio, if you're using Instant Run, and it creates an APK that doesn't really contain the contents of your app. It's really stripped down, just stripped down from resources, from code. That's because of the way Instant Run works. So the better way of doing it is always build the APK from this menu. This will build a full debug or release, whichever flavor you selected, APK. And then once it's built, this pop-up will appear on the bottom right, and you can simply click Analyze. And without browsing directories and so on, your APK will be open in the APK Analyzer. And I won't go through the UI here, because this tool has been in Android Studio for some time, like I said. But we have some nice improvements, like, for example, we're now showing dex sizes. So for every package, for every class, for every method even, you can see the approximate size in bytes that this piece of code is making your dex size bigger. There's also all kinds of statistics here, like the raw APK size, which always, whenever you install an APK, this size will always be the minimum size of the APK on your device. There's an estimate of the download size, because Play Store compresses your APKs for delivery, and so on and so on. But what I wanted to show you today is a sneak preview of the command line APK Analyzer, which we are releasing sometime very soon in a Canary update of the Android SDK tools. So if you get an update for Android SDK tools this week, I encourage you to go into the tools bin directory, and there it is, APK Analyzer in command line version. It does basically the same things as I just said about the graphical user interface, except whatever you would do in Studio, it's probably in the graphical user interface, it's probably you, the developer, just trying to find out some things. So you're being proactive, right? You're actually figuring out sizes and trying to do something with it. Whereas the APK Analyzer command line version is very nice to integrate if you have a build server, if you want to have some kind of monitoring from version to version, from build to build, creating some reports. Now you can do that easily. So this is the basic syntax. So you specify a subject, a verb. The subjects can be APK, so you can analyze some information about the APK itself, about the files inside, about the manifest, resources index. And let me quickly walk you through what you can do with the APK Analyzer. So like I said, you can, for the APK, you can look at things like summary, like the version code, the version number, file sizes. I'll talk a little bit about features and compare in a bit. You can simply list files and pipe files to the standard output. So this is basically making it easier to inspect whatever is in the zip file. Then you can look at things in the manifest. If you need to quickly figure out the application ID, the version name, just verify some things about the APK manifest, you can do that. Finally, for dex, you can actually list all the dex files. You can list for if you have any problems with multi-dex, if you're worried you will exceed the 64K method limit, you can actually print how many method references there are in every dex file. Dex packages is a pretty powerful tool. This basically lists all packages, classes, methods, and fields that are in your Dex files. And I will show that in a moment. And then Dex code lets you decompile methods if you actually need to look at the smiley code of a method or a class. And then for resources, you can, of course, look at the resource table. You can print all your configurations of all your string values, color values, whatever you want. And let me show you some examples of useful things you can achieve with that. So like I said, there are some basic commands just for inspection. You can look at download. You can look at sizes. And one important thing is when we were designing the APK analyzer, we thought this would be used by machines. That would be used in build systems. So the output has to be easily parsable by basically scripts. That's why the only thing we usually output is the actual value itself. But if you're a human, if you want to actually use it in your daily work, you can simply specify human readable sizes, and whenever the APK analyzer prints something, some sizes, it will actually make it easier for you. Then you can of course, like I said, the real power of this is when you use it in a build system and you start comparing one APK to another. So the simplest way to do it is simply use the compare function, and then it'll tell you the size differences between files of an old version of your app and a new version of your app, so that you see any regressions in file size. Like I said, the Dex packages command is pretty powerful. It lets you list all the things in your Dex files. So from packages through classes and methods in these classes, including the size contribution of the code to the size of your APK. The real power comes when you actually start using it with advanced scripting. So of course, everyone here probably knows some basic bash commands. So let's say I'm only interested in the classes in my Dex. So I have these classes. Okay, this is just one version of my app. But then I can diff this from v1 to v2 and see that actually someone, when implementing new features, added 2 new classes to my app, and this is how much space they're taking up. So again, if you integrate it into your reporting tools, into your build systems, build servers, you can get some really, really nice analytics from version to version and be able to figure out where these method references are going, where these sizes are going, and so on. Same thing with the APK features command. So APK features basically lists all the features that are required for your app, so that Play Store doesn't filter it for devices which don't have these features. And you wouldn't want one developer to, let's say, add a Bluetooth permission and then find out on the next day when you release that suddenly all devices without Bluetooth can't use your, maybe that's a stupid example because most devices have Bluetooth, but it's an example, that these devices can't access your app. And again, by having some kind of reporting like that from version to version, you can catch these problems early and make sure you don't release with a bug like that. Okay, and since we still have a few minutes left, let's see through how many tips we can go for some more debugging. Debugging ProGuard issues. So like I said, the APK analyzer has some nice improvements, and I think the main thing that we added at I/O time is support for ProGuard. So if you obfuscate your apps, if you use ProGuard to make them smaller, it's obviously more difficult to reason about the Dex code that's inside, because instead of class names, you see all these A.A.A.B, which is not really readable. So what you can do now, you can actually click this load ProGuard mappings and load the ProGuard log files from your build folder, and in the APK analyzer, you can actually see the classes again. What's more, if you're wondering, why is this class here? I'm not even using it. Why did this class persist in my APK and is taking up my methods and my size when I'm not using it from my code? You can actually right-click on it, find usages, and then dig into a chain that's keeping this class in your APK. So it turns out I am using it just indirectly, but from my activity, I'm using an optional that's using present from Guava and so on. So this is a nice tool for finding out why something's in your APK. By the way, another way to do it is if you add this why are you keeping specification to your ProGuard file, like this, why are you keeping class this, whenever you make a build, if you look at the log output, you will see ProgArt telling you why it's keeping that class. So it's keeping optional because I'm using it in my activity, and my activity is kept because it extends onCreate for activity, which is a library method that is kept. And here you get a nice chain of methods to figure out why something is kept in your APK. On the other hand, if a class is missing from your dex files, and something's not working in your app because you get a class not found exception or a method not found exception, you can actually click this button here after you load ProgArt mappings, and this is show removed nodes, and it will show every class and every method that was actually removed by ProgArt from your dex. And if you want to keep it, you can click generate ProgArt keep rule, and basically paste that in your ProgArt config, rebuild, and the class should be there. So that's ProgArt. By the way, when you upload an app using ProgArt to the Play Store, you want to still get stack traces that are readable for you. So remember to also upload ProgArt mappings to the Play Store, so that whenever something crashes in an app on a user's device, you can actually copy and paste the deobfuscated stack trace, and then simply paste it in Android Studio using the analyze stack trace method, and then you can use it as if you were, again, debugging an app locally. There's a few more tools that we're still improving or adding to Android Studio 3 that are useful for debugging. So for debugging UI, remember there's this tool called the Layout Inspector. And you can basically dump your view hierarchy. We've improved these panes on the sides so they're easier to use. You can see all the parameters of your views, figure out what's wrong when something's showing incorrectly on the device. For inspecting local files, so if you want to see what kind of preferences are saved in your app, if you want to pull down the SQLite database and inspect it on your computer, we have this thing called Device Explorer. You actually launch it here on the bottom right, and you can basically browse the connected devices file system and pull down files from your app and inspect them locally. You can even open the files and edit them here in Android Studio. So that's a completely new tool, very useful for just pulling down files. And by the way, we have these Play Store images now, which don't offer you root access, and you can still pull down files and do things from, if you have an app that's debuggable by using this run as command. Not many people know about it, I guess. That's how the Device Explorer is able to access your files. Actually, the way you use it is, if you try to list a folder of your app on a device where you don't have root access, you will get this permission denied because you're running as shell. If you do a run as command, then you can actually run any command as if it was your app. So this is the user that my app is running as. So this is pretty useful, especially if you don't have root on your device. And I guess we don't have time. Since the last version of Android Studio, there's this awesome tool called AppLinks Assistant, and I really encourage you to look over it. It has many tools for verifying these kind of intents that use HTTP URLs to open your app. So we have this new thing where you can actually click Add a test URL. Sorry about going quickly through this. I will post that online probably later. And the new thing in Android Studio 3 is it actually adds this tag into your Android manifest. And now whenever you break something with intent filters in your app, this inspection will actually break. So here's some test URLs that should be working with my app. But because I made an error and I didn't actually put HTTPS in my intent filter, I will break my build. So this will prevent you from actually releasing an app to the Play Store with broken intent filters, and then you wonder why some URLs are not opening in my app. You can also use it to debug problems with your digital asset links. Really encourage you to try it. But since we're out of time, again, thank you for listening. I will have some more tips online. Find me on Twitter. There it is. Thank you very much.